Hi everyone, welcome to Differential Calculus. Today we explore lesson 4.4, indeterminate forms of limit. Number one, indeterminate forms. We have four of them. A, indeterminate quotient. That is when the limit as x approaches a of fx over gx is either 0 over 0 or infinity over infinity. B, indeterminate products. Limit x approaches a of fx times gx is either 0 times infinity or infinity times 0. C, indeterminate difference. Limit x approach a of fx minus gx is infinity minus infinity. D, indeterminate powers. Limit x approach a of fx to the power gx is either 0 to the power 0, infinity to the power 0, or 1 to the power infinity. Because infinity is not a number, which is why most of the form involving infinity is indeterminate. Let's take a look at some example. Number 2, identify limit. Example, which of the following limit have indeterminate forms, and if so, classify its form. In A, we have limit x go to infinity, 2x squared plus 1 over x squared minus 1. In order to determine, or do just do the direct sub. Direct sub, we have 2 times infinity square plus 1 over infinity square minus 1. Well, infinity is the numbers just keep going bigger and bigger and bigger. So it's going to be infinity over infinity. Indeterminate quotient. In B, limit x go to infinity, x to the power 1 over x. Same thing, direct sub, infinity, 1 over infinity. We know 1 over infinity is 0, because when we divide a real number by a number getting bigger and bigger and bigger, the quotient is smaller, 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 and eventually it's going to be 0. Infinity to the power 0. It's indeterminate power. In C, limit x go to 2, x over x minus 2. Direct sub, we have 2 over 2 minus 2. So that is 2 over 0. This is undefined because it is not an indeterminate form. Cannot divide a real number by 0. Let's move on. D, limit x approach negative infinity, x e to the x. Direct sub, we have negative infinity, e to the negative infinity. Well, that would be negative infinity. E to the negative infinity is 0. An indeterminate product. You can actually turn this one into a quotient if you use the fact that e to the negative infinity is 1 over e to the infinity, or you can write this one as negative infinity over e to the infinity, and you say that, oh, this is negative infinity over infinity. It was an indeterminate quotient. So we can always turn an indeterminate product into an indeterminate quotient. E, limit x go to 0 on the right side of x, ln x. Okay, let's do a direct sub here. Zero. We know ln of 0 on the right side is negative infinity. So up negative 0 times infinity, which is an indeterminate product. F, limit x go to 0 on the right side, 1 over x minus cosecant x. Do a direct sub, we have a 1 over 0 on the right side. Cosecant is 1 over sine of 0 on the right side. When we take 1 and we divide by a number approaching 0, the quotient is getting bigger and bigger and bigger. So we have infinity minus same thing, infinity is an indeterminate difference. Three more examples to go. G, limit x go to infinity, 1 plus r over x to the power x. Direct sub going to give us 1 plus r to infinity to the power infinity. Well, if r is the real number, and when we divide by infinity, we're going to get 0. So we have a 1 to the power infinity. Oh, indeterminate power in h. Right? Direct sub e to the 0 minus 1 minus 4 times 0 over 0 square. So what we have here is 1 minus 1 over 0. 0 over 0. Indeterminate quotient. And the last one, limit x go to 0 on the left side, ln negative x over x minus 1. And you got to be careful here. Do a direct sub. So when x approach 0 on the left side, we would have ln of negative by a negative number. So that is a positive number. It's going to be a ln of negative 0 on the left side over 0 on the left side minus 1. So what we have is ln of negative of a negative number is positive. So 0 on the right side over negative 1, which is negative infinity over negative 1. And that is just infinity. it has no indeterminate form. The limit is just infinity. You got to be careful on these direct sub to figure out whether the limit has an indeterminate form or not. Because if it has an indeterminate form, there's a way that we can figure out the limit. And that is in the next video. Thank you for watching. I hope you found the content useful. Please like and subscribe to help the channel grow. I will see you in the next video.